I'd like you to take a regular piece of paper and fold it in half. Repeat this as many times as you can until you can no longer do that, and count how many times you're folding it. You can experiment with different types of paper, thinner paper, bigger paper. You can experiment with different ways of folding it. Let's keep track. So if you have one fold, you are essentially doubling the sheet, and you have a thickness of 2 sheets. With 2 folds, you're doubling it again, and if you were to cut through it, you'd really be cutting through 4 sheets of paper. With 3 folds, you get 8, 2 times 2 times 2. With 4 folds, you get 16 sheets, 2 times 2 times 2 times 2. With 5 folds, you double it again, you're at 32. With 6, you're up to 64. I couldn't fold it more than 6 times, so my resulting paper ended up sort of 64 sheets thick. Maybe you could get one more, 7, but I think that's probably the limit of what anybody can get. So mathematicians love shortcuts. Mathematicians, multiplication really is just a shortcut. It's a shortcut for repeated addition. And similarly, exponents are really just a shortcut for repeated multiplication. So instead of writing 2 times 2 times 2 times 2 times 2 times 2, you can see that we can write it as 2 with a little 6 beside it. And that's pronounced 2 to the power 6, or 2 to the 6th. Even 2 itself we can write in exponential form as 2 to the power 1, although we don't normally write it that way. So from now on, we'll refer to just 64 as the standard form. It's the simplest way of writing a number. But obviously there's many ways of writing the number. And repeated multiplication, as long as it's the same number that's repeated, is another way of writing a number. So 2 times 2 times 2 times 2 times 2 times 2 is another way of writing 64. And then 2 to the power 6, or 2 to the 6th, is a power. Now, in that expression, we have to be able to distinguish between the parts of it. So in 2 to the power 6, or 2 to the 6th, the 6th is the exponent, and it's usually written a little smaller and as a superscript, so above and to the right. The 2 is referred to as the base, and it's always to the lower left and a little bigger. The whole thing is referred to as a power. And you can pronounce it as 2 to the power 6, 2 to the 6th power, or 2 to the 6th. You saw there was a couple ways that are slight exceptions to that rule. If you have an exponent of 3, you could say 2 to the 3rd power, or 2 to the 3, but more commonly you'll say 2 cubed. And similarly, 2 to the power 2, or 2 to the 2nd power, you'll more commonly say 2 squared. And the reason for that is obvious. If you think of a diagram of a square, and you go to find the area of this square, you end up multiplying one edge length by itself. So if we have a square with edge length of 3, when we go to find the area, we're actually taking 3 and multiplying it by 3, and the result is 9, but it's really 3 squared. All right, and so that's an alternate form of 3 to the power 2, or 3 to the 2nd power. Similarly, if we have a cube and we're trying to find the volume of the cube, we end up multiplying the edge length by itself and then by itself again. So for instance, if we have an edge length of 2 and we find the volume, it's going to be 2 times 2 times 2, 2 to the power 3, or more commonly 2 cubed. So with exponents, we have to pay attention to order of operation. So there's a variety of different acronyms for order of operation, and you may be familiar with BEDMAS. Some places they're more familiar with something called Pemdas. Different languages obviously are going to have different acronyms, but in every case it's going to be the same rules. So the acronym that's typically used here is BEDMAS, and the B stands for brackets, the E for exponents, the D for division, the M for multiplication, the A for addition, and the S for subtraction. Now, division and multiplication are really treated the same way, and addition and subtraction are also treated the same way. So what this means is brackets have to be evaluated first, followed by exponents. But exponents, quite critically for our purposes, get evaluated before division and multiplication. So when you see something like -5 squared, what do you do first? Well, the negative is treated like a multiplication. So the exponent 2 acts only on the 5, and so what you really have is 5 times 5 with a minus sign in front of it. So the result is -25. A lot of students find that very confusing because what they really want to do in this case is square the base, -5. In order to really do that, you need to put brackets around the -5. And then when you have -5 times -5, the result is +25. So if you try this on a calculator like a TI-83, it will pay attention to order of operation, and if you type in the -5 squared without the brackets, it'll tell you -25. Sometimes, of course, it doesn't matter. If your exponent is odd, then it doesn't really matter whether you have -2 to the power 3 in the brackets or not. You're still going to get -8. But the actual operations have been done in a slightly different order, and you should pay attention to that.